Okay. Assalamu rahmatullah. Chapter 3 is talking about the chemical bonding. In this chapter, we talk about the stability of atoms, how the atoms become stable. Also, we talk about the valence of atoms, and we talk about the different types of bonds that exist between the atoms, which are the covalent bonds, and its three types of the covalent bond, single, double, and triple. Then the second type of bond is the ionic bond, and the last part in this chapter is the exercises. Okay, as we know, the most elements of the most matter in the natures are formed either as an element or as a compound. Rare of the matters that are exist as monoatomic. But why the atoms form compounds or form molecules in different form? For examples, we have as an example an oxygen gas. Why oxygen exists as O2, nitrogen elements is found as N2. Why hydrogen and oxygen can combine together to form water, and so on, like carbon dioxide. What is the reason for the different atoms to form a compounds or different compounds in different forms in nature? This is the atom itself is searched to be stable. It needs to become stable. For an element or an atom to become stable, it must have a saturated energy level. Their energy level must be saturated. لازم يكون عندهم complete energy level in order to become a stable element or a stable atom. For this reason, rare of the elements are stable elements. There are two ways for an element or atom to become stable, either by having an 8 electrons. If an element or energy level is completed by 8 electrons, so it satisfies the octet rule. If the energy level is saturated by 2 electrons, so we say that it satisfies the duet rule. Octet means 8 and duet means 2. The energy level is complete or saturated. For example, in atom 1, this first energy level is energy level K, and there is 2 electrons, so we have a complete energy level K level with 2 electrons. So this element or this atom is an stable atom since it have a saturated energy level only K2. For atom 2, we have 2 energy level K has 2 electrons, and the level L has 2 electrons. As we see, this energy level of the outer energy level is not complete, not saturated either by is not saturated by 8 electrons. This level of this energy level is not complete. Also for atom 3, we have K2 in the first energy level K. L, we have 4 electrons in L. Also, this energy level of outer energy is not completed or saturated by 8 electrons. For atom 4, we have K level and L. K is 2, and we have 1, 2, 3, 4, 5, 6, 7, 8. L is 8. These two energy levels are complete or saturated. This element is a stable element, so it can exist as monoatomic. The only elements that can exist as a monoatomic in nature without combination with other any elements or atom, and the elements of column 18, they exist as monoatomic since they have a saturated energy level. For the atom 5, we have K, L, and M. The level M has 1, 2, 3, 4, 5, 6, 7, 8. K2, L8, and M8. So it is also have a saturated energy level, so it is a stable element, so it exists in nature as one atom. The last atom 6 as an example in this figure, we have K, L, M, and N. The outer energy level has 2 electrons. It have a K2, L8, M8, and 2. This energy level is not complete, so it is unstable element, so it will search for another element, for another atom, in order to combine with it to become a stable element or to form a compound. To talk about the valence of the atom or the valency, there is two meanings for the valence of them. The first meaning here, it is the number of unpaired electrons in the lowest dot symbol. We can determine what is the valence of atom or the valence of atom by counting the unpaired electron in the lowest dot symbol or the number of single dot electrons. For example, hydrogen has only one single electron or unpaired electron, so the valence of hydrogen is equal to 1. Nitrogen has 1, 2, and 3 unpaired electrons or single electrons, so valence of nitrogen is equal to 3. For fluorine atom, we have only one unpaired electron or single electron, so the valence of fluorine is equal to 1. We count the unpaired electron in the lowest dot symbol in order to determine the valency or the valence of atom. We must not to have a misconception between the valence electron, which is the number of electrons in outer energy level, and the valence of atom, which means the number of unpaired or single electron in the lowest dot symbol. Or there is a second term or meaning for the valence of atom of the valence of electron. It represents the number of electrons that can either lose, gain, or share. Elements or atoms when make a chemical reactions in order to become stable, either by losing electrons. Some atoms have a characteristic or property to lose electrons. Other elements or atom has a property to gain electron, and in some cases, some element can share electron in order to become stable or to have a saturated valence shell. Which element can lose or gain or share in order to become stable? The following are as follows. Column 1, any element in column 1 has a valency equal to 1, since every element in column 1 loses 1 electron. We must memorize it. Element 1 loses 1 electron, so the valence is equal to 1. Okay. Element of column 1, every element in column 1 has the valency to lose 1 electron. Also, the valence of every element in column 1 is equal to 1, since it can lose 1 electron. Any element in column 2 has a valence is equal to, since it loses 2 electrons in order to be stable. Any element of column 14, the valency is equal to 3, or the valence of the atom is equal to 3, since also it loses. Is an elements of column 1, 2, and 3, all of them has a property to lose electron. Column 1 lose 1, column 2 lose 2 electrons, and column 13 in order to be stable. For example, lithium, which has an K2L1, it has 1 valence electron. It belongs to column 1, so the valence of this lithium atom is equal to 1. When it loses this electron, it will have an energy level which is equal to 2, which is a saturated energy level. So we have a saturated energy level, so it become stable. For example, magnesium, which has an electron configuration K2L8M2, it has two valence electron. It exists in column 2, so the valence is equal to 1. It loses these two electrons. The electron configuration become K2L8. We eliminate these two electrons, so we have a complete energy level. It is the outer energy level is saturated by 8, so it satisfies the octet rule. Also the same is for column 13. For hydrogen, hydrogen has also diamond. Hydrogen has a valence equal 1 since it need hydrogen need a 1 electron. In grade 9 we talk about hydrogen. Hydrogen always need 1 electron. We can't say in grade 9 hydrogen loses electron. All the questions, all the exercises about hydrogen, if we want to determine the valence or the valency of hydrogen atom, we say the valency of hydrogen atom is equal to 1 since it need 1 electron, because hydrogen has an electron configuration K1. In order for this energy level to be saturated or completed, it need another 1 electrons. It need another 1 electron in order to become K2, which is a saturated energy level. So we say it need in order to become as K2 energy level for this reason. Elements that are found in column 14, it has valence equal 4 since it needs 4 electrons, also need 4 electrons. The other column, which are 15, we must memorize them. Column 15 has valency 3, column 16 has valency 2, column 17 has valence is equal to 1 since they need either they satisfy the stability or attain stability either by needing 3, 2 or 1 electron. This can attain either by share electron, can acquire stability by share electrons, or by gaining electrons. This element either attain stability, only column 15, 16 and 17 either acquires the stability or attain stability or acquire the octet rule, satisfying octet rule. They either by sharing electrons with other elements, or in some chemical reactions they will gain these electrons. Whereas elements of column 18, the valence is equal to 0 since it has property neither to lose or need electrons. They are stable since elements of column 18 they have already have a saturated energy level. Okay, so for these elements we determine the valence of the atom by counting the single dot electron in the lowest dot symbol. Beryllium has 2 single dot, valence is equal to. Boron has a 3 single dot, so 3. Carbon has 4 single dot electron, so the valence is 4. Nitrogen has 3 single dot electron, valence of nitrogen 3. Oxygen has 2 unpaired electron, valence is 2. Fluorine has only 1 unpaired electron, valence is 1. And neon has no valence, has no single or unpaired electron, so the valence of neon is equal to 0, and you can complete the table by yourself for the other elements.